Welcome to EDU World Space.
In this problem, we're given various properties about an area, about the centroidal axes, and we're told that the area moment about the centroidal x-axis is 1,200 inches to the fourth, and about the centroidal y-axis is 300 inches to the fourth, which means we can immediately get this where the center of Mohr's circle is by taking the average of these two, and that's 750 inches to the fourth. We're also told that if we rotate the axes 30 degrees, then our new centroidal area moment about the new x-axis is 1,450 inches to the fourth. So I've kind of tried to draw a Mohr circle. We know where the center is, and we know that if we rotate it, and here 60 degrees, because 30 degrees in the axes, so 60 degrees here, we wind up with a slightly bigger area moment about the new x-axis. We know x is bigger than y, so we know this one was x. And so, and I'm not sure if xy is negative or positive, but I'm assuming it's negative, and we'll figure that out. But so we know if we rotate that. So what we need to do is just use some geometry here, and the geometry we have is that we know that whatever this is the radius, so this radius here, so this is a total of 60 degrees, and I've called this phi here, and so the radius times cosine of 60 minus phi, that angle, must be equal to I bar x minus c, okay, that distance. And so we have this equation. And then this one, we know that the radius times cosine of this angle, phi, must be I bar x prime minus c. Okay. So we have two equations and two unknowns. We know what c is, and we don't know what r is, and we don't know what phi is. But we have two equations for those, and we can solve them, and we get that r is 709 inches to the fourth, and phi is 9.4 degrees. So this is 9.4 degrees. Which seems to make sense because I think I've drawn it roughly right. So now we need to figure out some other properties. And we know that IXY, we actually weren't even asked to calculate that. So again, we could get it, we could find it. I didn't actually get a numeric value for that, but we could find it. It is minus r times the sine of 60 plus minus phi, actually. But we weren't asked for that. What we were asked for is the orientation. And so we know that the orientation, to get to the principal axes, we know we need this angle here, or we need half of that angle here, and that angle is 60 minus phi, and so we need to take half of that, and that we get 25.3 degrees, so we need to rotate it counterclockwise. And since we know C and we know R, we can get these two guys. And the maximum principal area moment about the centroidal axes, again these are centroidal, is 1,459 inches to the fourth, and the minimum is 40.5 inches to the fourth. And so that makes sense because we can see that when we rotate 30 degrees, we get pretty close. We overshoot basically a little bit by that much, 10 degrees on here. And so these two values here are actually pretty close to our what our maximum is, and this one especially. So again, this is bigger than both of those, and this is smaller than anything of the area moments that we had before. So this all makes sense.